So wrap. Oh, exactly. Somebody once came into. Yes, that is not good. Somebody once came into my lecture and asked me how to do online programming again. And I said this 27-minute long demonstration video, and they said that video is too long. They don't have the time to watch that. In which case, I just told them I can't explain object-oriented programming in less than 20 minutes. That's just the way it is. So, apologize. That is one of the longer videos, but that's also what you guys are paid to be here for. So, as always, there is a wealth of knowledge and information on the internet as well. Most C++ object-oriented programming videos will be good. Any object-oriented programming video in general, C#, Java, C++. Look, like I said, most of the videos in this class I aim to be under 7 minutes. But the programming demos are just difficult to do that. If I made them under 6 minutes, I'd have to have 5 of them, so you'd still get 27 minutes of video. It is what it is. All right. So we have to review our field, our fields, our constructor, our getters, which let us get the values of our individual fields, our setters, which allow us to reset values of our individual fields. Then we have both of our ways to create a new object. First, using the shorthand constructor syntax, and then the longhand by using our normal variable initialization syntax and calling the constructor individually. And finally, we have calling a method on an object. So this is an existing object. This is our Nissan 240SX. And then we are calling our get string description method on it. So we have all of those things done. So we are almost done with our entire lecture. So before we move on, this sign is my font. This is my special font. It is ! sign. My font turns it into that sign. So you don't have to worry about looking exactly like that. That's just what my font does. If you would like my font, some people do ask for it. You can go to, it's got a GitHub page. It's called FireCode, right? So you just go to the releases over here, and you download the font and the zip. Double click to install it, and then in your Visual Studio, you can go to Tools, Options, and then you go to Font, and it should show you the font selection here. So I chose FireCode. If I chose something like, not Lucidia Console, but Cascadia Code, which I believe is the default one, you would be able to see. Well, it's still using the code ligatures, so I don't know why it's using the code ligatures. But yes, I do prefer FireCode. It is my baby. All right. So the last thing we need to do is we need to look at other mechanisms for creating objects. Because what if I wanted to make? I'm just come up here. We're gonna make a vector of cars. We can do that by saying std vector, and for my type, putting a type of car, and I'm going to say garage. I'm going to say I'm going to make a garage, and I'm going to make this equal to an std vector of cars for the size of two car garage. Now, if I were to try to build this right now, it should fail. If I were to try to build this right now, my build fails. It says no appropriate default constructor available. So, pop quiz. Right now, I am creating a vector of cars, right? And as we saw previously, when we create like a vector of integers, right, we give it a size, what is stored in that vector by default? A default value of whatever that data point is. So if it's just a vector of strings, right, it saves an empty string. If it is a vector of integers, right, it saves as all zeros. So if it's a vector of cars, it needs to save a default value of my car. That is a car if we do not provide it with any values. And right now, there is no manual definition of a default car. We didn't make one. So since we didn't make one, it doesn't exist. And as a result of that, since the vector requires that, it says that it can't do it. It cannot make a vector of cars right now because we have no default initialization of cars. A vector is just like creating a vector is just like creating any other variable. It just has more than one value. That's it. So instead of making one int, you're making 3 ints. You know, it's a container. It's like an ice tray or like one of those pill things, right? Just an empty container can hold X amount of things. Put things in there. All right. So what I need to do is I need to make a way to have a default initialization of a car. So the way I'm going to do that is I need to make a new constructor. And this constructor will take in no values. When a constructor doesn't take in any values, it'll create a default initialization of the object that is an object that is created when you do not give it any values. And this is known as the default constructor. Since this is the default constructor and we have another constructor, this constructor is typically known as an overloaded constructor. We talked about method overloads before. Method overloads are the methods that have a same identifier but a different return type parameter list or both. This is exactly what that is. This is going to still return a car, but it does not have a parameter list. Making this a default constructor and making the other constructor an overload.
Why are so many people? Why so many people?
So now I just need to set the default value.
How many people are left?
I can make these whatever I want, but I'm going to do this in a way that makes sense.
Just 3.
Number 1, I'm going to set my year equal to -1. I'm going to set it to equal to -1 for 2 reasons. Number 1, it'll very, very easily identify it to me as a developer as a default object. And number 2, the only way, literally the only way for it to get this way, since we made our setter only accept values that are greater than 1900, the only way that it can have a year of -1 is if there's a bug, like there's data corruption, or if it was intentionally created as a default object. So that's just for me, because I'm smart guy. Then I'm going to make my make equal to an empty string, and then I'm going to make my model also equal to an empty string. Which means now, if I were to put a breakpoint right here and run my application, it should build, and I should see a garage here. So that means my garage vector was created correctly. And if I were to observe the garage, I can see the items stored in the first index and the second index, that is index 0 and index 1, are both cars that were initialized with the default constructor. So you can see right here, index 0 is a car typed value. And if I expand it, we can see it has a year, make, and a model, and the year is set to -1. Which means, by default, the empty garage has 2 default cars in it. Right? Does that make sense? Alright. So, if we were, again, conceptualizing this as a real-life representation of a garage, if I looked into this garage right now, I would see nothing, because there's default cars in there. Default cars are basically an empty parking spot, right? Which means, if I look into my garage, the first position, and if that first position is a car that is an empty space, that is a default car, then I can set garage car, the garage 0, equal to my Nissan 240SX. So this vector of cars can be used in something like, theoretically, you know, it could be used anywhere you can use a vector, right? The vector of cars specifically, you could use this. So we know, right, that car 0 is going to give us a car type object, right? It's car type object. Car 0 is an identifier, garage 0 is an identifier for a car the same way that Nissan 240SX is, the same way that Ford F-150 is, which means directly on this identifier, I can call get year, right? And it will return the year of the car in index 0. I just chain those two things together. And then if I check that year, and if that year is less than 0, right? Because remember I made my year -1 for default, then that's an empty space. So we can make this easier for ourselves. We can say a car parking spot is equal to garage 0. So we can pull that car out of here. And then if we say, if the parking spot, if we get the year of the parking spot, and the year is less than 0, then we know that that's actually not a car, that is a parking spot. That is empty space, that is a default representation of a car. That is what we can refer to as a null reference. It's not an actual null value. It's not a value that doesn't exist anywhere, but it is a representation of an empty space in our collection. Said a lot there. Does anybody have any questions about that? So to review, if I create a vector of a custom object, in this case it's our cars, of a specific size, in this case it's 2, by default, whatever we defined as the default initialization of a car will be represented in those two spots. I set a default representation of a car as a year of -1 and an empty string for the make and model. Which means if I pull out one of those values before I put something else in there, both of those spots should contain car objects that if I call the get year method on them to retrieve the value of their year will be -1. If I pull it out and it's -1, then I know I can override that default value with a real value because it wasn't any real data. Yeah, that's exactly right. I know those spots are empty based on how I defined what an empty spot should look like, basically. Any questions about this so far? All right, so now that we've done that, right, I can take this functionality and I can put it into a method to reliably search my collection, so search my garage for an empty spot and put a car in there. I'm going to make it have a bool return, so that way we'll know whether or not it was able to find a spot and put the car in there. And I'm going to say, place car in garage. I'm going to take in a garage that I'm going to put a space into, that I'm going to put a car into, so I'm going to make a new, the first parameter is going to be a vector of cars called garage. And the second one is going to be the car to add, so a car. So the first thing I need to do is I'm going to set up, this is a bool return. I'm going to set up a variable called bool result, and I'm going to set it equal to false. Then I'm going to return the result. There we go. Any questions about that? That makes sense, right? Cool. The next thing I'm going to do is the same thing that I did down here, right? I am going to say for int I is equal to 0, while I is less than garage.size, to the garage at that position. So for instance, the first time I run this, it's going to be index 0. The second time I run this, it's going to be index 1. So this is just looping through a collection. Same way we do all of the time. Yes, that's exactly right, Jim Michael. I can make a vector of cars because we have access to the car class here. A vector can hold a collection of any type of data, including custom types that we make ourselves. So it can do an int, it can do a string, but it can also do a car. All right, so this will be a car. Whether or not it's default car, we do not know. So now we do that other part, right? We do the if statement. So we say if the current spot, if we call get year on it, if the year is less than 0, then that's actually a default initialization of a car. That is a default car. That is a null reference. That is an empty space, which means the spot garage I can take in the car that we set, and then we will set our result equal to true because we were able to find a spot to put our car into. Does that make sense? Anybody have any questions about that? Cool. So let's put a breakpoint here and let's run. So we do that. Pull this over here real quick. We should be able to see our garage. Assuming it ran. I didn't call the method. That's an important part of this. So let's do that. Let's actually call this method. Let's get rid of this. And we're going to say, let's say place car in garage. And I'm going to pass in my garage as the first thing. And I'm going to pass in my Nissan 240SX as my second one. This is where I would put my Nissan 240SX if I had one. So we're going to run it. And now we see, here's the garage. If I expand that, we can see, boom, auto duplication should hack. I now have 2 Nissan 240SXs. Good call. Now, can anybody guess why I now have 2 Nissan 240SXs instead of 1? I'll tell you, if I had $50,000 to buy cars, my first choice would not be a Nissan 240. The method checks for a default car. Yes, this method does check for a default car because it checks to see the year is less than 0, which we set the default car as having a year of -1. So that will show up. Yeah, that's exactly right. So both cars have a year of -1, which means it put it into both slots. Both slots had space for a Nissan 240SX. We put a Nissan 240SX in both slots. So what we need to instead do is once we find any open spot, to stop looking for additional spots. We don't need that. Which means if we find a spot, we break out. That's it. So we stop looking. So we look at it again. Now when we look at the garage, the first spot will have a car in it, and the second spot will still be an empty spot. Done. All right, well now, what if I want to pull a car out of the garage? What if I have a garage that already has 2 cars in it, and I want to pull something out? Well, we can do the same thing, right? We can say, bool, well actually we'll say car, we'll return the car, forget it. Get car from the garage, right? So we'll take in another garage. So std vector of cars called garage. And we will put in something that we're going to use to identify the car. I think the model will be fine, right? Say I want the 240 today versus the 150. So we're just going to take in an std string model. I'm going to use the model to identify the car. All right. Scroll the syntax, highlight that, maybe? No? Save, scroll the syntax, highlight that. don't know why it's not syntax highlighting. It should work fine though. All right, so in here, hold on. That's really bothering me. There. So in here, we're gonna do the same thing, right? First of all, we're gonna set the car, we can set it equal to a car, that's fine, and then we're gonna return car, right? That same thing we always do. Then, we need to check all the spots. So we'll say for int I is equal to 0, while I is less than garage.size, I++. Remember I said that this is like the bit of code that I've written the most of my entire life? I was not joking. All right, then we're gonna say car, current spot, is equal to garage I again. Just gonna check that current spot. And then we're gonna say if, it keeps hitting my insert key, I don't like that. If we check the current spot's make now, or the model, because that is the model that we're trying to do, right? If the get model of the current car we're looking at is equal to the model name that was passed, then we're gonna set our car equal to that car. So we're gonna set the car variable equal to current spot. Or we could set it equal to garage I. Either one would work. It's the same thing, right? We also need to stop looking. But there's one more thing we need to do, and that is we need to remove the existing car out of the garage, right? We're returning the car, right, for the method, but we do need to take that spot in the garage and put an empty car in there. So I can do exactly what that sounds like. In that spot now, we're going to replace the data of that with a car initialized with the default value, right? Because again, a default car represents an empty space. So if we want to remove, quote unquote, a car from the garage, we replace it with an empty space, which is a default car. So now, if I call, what did I say, get car from garage, now what I need to do here is I need to pass it a garage with cars. So I'm just going to do that. I'm going to give it a garage full of cars by putting in by initializing that vector with values. So we're going to say std vector. Actually, this should work. Hold on. And then we're going to say I want the Ford F-150 and see if that fixes it. Now, oh, because I spelled that wrong. 240 XX. Not gonna work. And then the Ford F-150 is also spelled wrong. There we go. So now I'm sending it a garage with two values in it already. It's gonna be the F-150 in the garage, and I want the F-150 out. So this should say car. I don't know. New car. It's not really a new car, but it's a car. So this should pull out the F-150. So let's run it. So now new car is equal to an F-150, and the F-150 should be removed from that collection. But also, if I come here and I say like car, if I say new car now, we reinitialize new car with get car from garage, and I say I want to pull up my Honda Civic, and I run it. It's gonna say new car is still equal to an F-150. So that's not working correctly. So there's a bug here. So let's check out what that is. So car is equal to default car. If the model matches the model that we have, let's put a breakpoint in there because I do want to see what's going on. Okay, so now we are here. This is the first time we ran the method. Car is equal to an F-150. We're going to run it again. Car is equal to equal to a default car. So we continue out. So I know what's happening. What's happening is I'm stopping on this line as opposed to the next line. So I'm stopping it before the method runs. So that's why car was a still F-150. So now when we look at it, it stops here. New car is now empty. No, there is no Civic. That's the problem, right? So it searches in there for a Civic, and when it doesn't find a Civic, it just gives us a default car because there is no Civic. Which means on my end, right, if I'm a developer, I can set up a method that says, like, for example, if I take new car, and I get the year, and it's greater than 0, I can say SD cout found a plus new car dot get description, right? Or get string description, and then plus exclamation point. Or else say std cout no car with that model was found. So this allows me to create like functionality now, right? So if I run this right now, we're gonna check the year of new car. The year is gonna be greater than 0 because it's a the year is gonna be less than 0 because it's -1 because it didn't find the Civic, and it's gonna say no car with that model was found. But if I comment this line out, also if I come up here and I make some line breaks because it's not. I didn't do end lines. I'm gonna do new line, and an end line. So now when I run this, we're looking for the Ford F-150 instead, and it says we found a Ford F-150. So it allows me that bit of functionality. So this up here, again, we just search through the whole collection. We'll place it. So we initialize the default value. We then search the entire collection. We then observe an individual spot. If that spot contains a predefined, because that's we made it, default value, place the car, stop looking, and return the result. So pretty similar to what we've done before, right? We just use our, instead now, we are using our objects in connection with all the things, right? We learned how to do vectors. We learned how to get stuff in and out of vectors, right? So we're doing in and out of a vector. We learned how to make a collection. We learned how to loop through a collection. So we're looping through a collection. We learned how to call individual values from individual fields using getters. So we're doing that. And we learned how to check two different values against each other. So we're doing that. We're doing if statements to check to see if a year is less than 0 because we specifically set up our application. This is the whole class in one method. So if you guys can understand this, you're in great shape. And if you can't understand this, ask me a question now. Let me ask you guys that have taken this class before. Is this not very helpful? Does this look familiar to you? This right here, do you understand this? fastest spot. Straight up. Going down here, same thing, right? We are going to initialize a default car. We are going to search through our garage collection. We are going to reference the current item, say current object. We are going to compare the model against the provided model. If it matches, set car to that model, and then empty the space by replacing it with a default car. And of course, stop looking. So the same thing, it's the same process, except instead of replacing a default spot with a car, we're replacing a car with a default spot. Yeah, you can screenshot this, but you can also watch the recording. There's going to be a recording of this. So does this make sense? Now don't worry, if it still doesn't make sense, you only get part of it. We are going to do the thing that human beings should do and how human beings learn, and that is we're going to do this thing at least 3 more times because I'm just going to need you to in order to make stuff work. You'll see it's a pretty common pattern, which means it's going to come up quite a bit. But like I said, looping through a collection is like the most common thing that I do, so you'll see that in practice. Yeah, so this is taking an existing empty spot, or this is taking a car in a spot and replacing it with an empty spot, and this right here is taking an empty spot and replacing it with a given car. Now we know it's an empty spot because an empty spot is defined by a car created with the default constructor, and in my default constructor, I intentionally created a field, a value for a field that would be easy to identify. In that case, it's the year that's -1. So that's why when I get the year of a car, if it's less than 0, I know that's a default car, because I set that up. So that's a good plan. Silence across the room. Well, I'm going to tell you what, we're going to take our last break. So it is 3:50. We're going to come back here at 4:05. And then we will wrap this up. And then we are going to go over not only your lab 7, but your lab 8. So I'll see you guys back here in a little bit. I'll leave this up here as well. How we doing? Any questions? All right. So we are going to spend the last bit of this class looking over lab 7. I'm going to go to FSO. I'm going to download down lab 7. So this is if you guys are on campus, this is the way you're going to focus on today, assuming you have completed your practical. If you've not yet completed your practical, please work on your practical. Again, if you do not accept late work, if you do not give extensions, it will automatically be graded to 0. So get that practical done as most as you can. You have until Monday to complete lab 7. So here we are in lab 7. If I were to run lab 7 right now, we're going to give it a second. it's going to say nothing ran because we need to uncomment this define line. So we're going to come back to that. But nothing runs right now because nothing runs. So the way the Lab 7 works is each of the tests is associated with a particular class we have to make. So you can see here, 1 and 2 are the 1 and 2 are the book class. 3, 4, 5, 6 are the circle class. And then 7 and 8 are the text codec class. All right? So in order to complete these tests, you must first complete the class. The reason that these don't run is because the class hasn't been created. So for example, we have the book class. This is the line that you will uncomment. And when you uncomment it, it will uncomment all of these. So these will run. As it stands right now, there is no such thing as book, so book will not run. So I'm going to recomment that line. None of these tests will run unless the class is completed. So you need all the functionality that is required by the methods in order to do that. So, book class. So this is where your book class should go. For information on what you should be putting into your book class, we're going to go to FSO. So on FSO, you're going to see a series of instructions for each one of these classes. So for example, your book class, here is what it should look like. Here's the to-do, undefine the books. Here is your book class, create class book. Your book class should have two different member variables. They're going to be a string title and a string author. It's going to require a default constructor. The default constructor should set the title to Moby Dick and the author to Herman Melville. You're also going to need an overloaded constructor that will set the fields equal to whatever information is passed. Finally, you're going to need getters for both the author and the title. That's it. Your book class is complete. So you have a default constructor, an overloaded constructor, and getters for all of your fields. Then, for your tests, it's just going to look like this. For the default one, you're just going to say book, book, return book. And for the overloaded one, you're going to say book by calling the overloaded constructor and returning book. So that means here, actually for test 1, you don't need to change this at all. This will just work once your default constructor is created. And for test 2, you just need to create and return a book using these provided parameters. Again, it'll look like this. Next, in the circle class, you guys will need to create a circle object that has a certain amount of fields. So here in the circle class, you can see define circle. You're going to have an X, Y, and radius. All of these are going to be integers. You're going to need an overloaded constructor. You do not need a default constructor here. And then you're going to need getters for X, Y, and radius. In addition to those, you're going to have additional methods. Those additional methods are going to be get area, get circumference, and get diameter. So these are going to return those particular things of your circle. Pay attention here because the area returns a float. Now, for pi, we can either import the math class and use the pi constant, which I'm not going to make you guys do. Instead, you guys are just going to use 3.4f, that is 3.4 as a float, as your value of pi. So your calculations will be checked up against math that is using 3.14f. If your calculation is slightly off, that's why. If you don't know the equation for the area of a circle, I provide it for you here. So this should be a method called getArea that returns a float that represents the area of your circle based on the radius at 3.14f as the value of pi. Yeah. You're asking if you can make a member variable as pi? Sure, that's fine. I don't care. telling you that. You guys can do that. People online aren't going to know what I'm talking about, so they do that. All right. So that's your shape class. Finally, we have the text codec class. This one throws people for a loop a little bit. So we're going to talk about it kind of in detail here. First of all, is anybody familiar with the Caesar cipher? A Caesar cipher. So if we look up a Caesar cipher, a Caesar cipher is a method of encoding messages by offsetting all the characters by a particular shift. So here you can see this is the text, right? And it shifts it by 7 right now. So this is the ciphertext. I can change it to shift it by 1 to make it a little bit easier to see, right? So this is the shifted text. It just takes all the existing values and shifts them up by 1. So to decode it, you shift it down by 1, right? So the text codec is going to create a Caesar cipher. So you're going to start off by creating your text codec class. It only has one field. The field is a short int called offset. This is how much your messages will be offset and shifted for your Caesar cipher. Then we're going to make an encode method. So under your text codec class, you're going to make an encode method that will shift a provided string message by your offset. You don't need to write it. I wrote it for you. So all you need to do is make the encode method and copy this code in there. If you look at this correctly, it says it's going to go through each character inside of the message, and it's going to reset it to a char after we add the offset. So it's going to take each character, add the offset, cast it to a char, put it back into the message. So it's going to take that string and it's just going to shift all the characters, and then it's going to return the completed string. You don't need to do it. I did it for you. Right, cool. Then you're going to create an object using a provided offset. So in your test, it says you're going to create an object using the provided offset, and then once you've created that text codec object, you're going to pass a message to it. So you're going to call the encode method on the object, passing the provided message. This will give you a encoded message. So what you return here is the result of the encode method after you passed it the message and after it uses the offset stored in the object, right? So this is 3 parts, right? Number 1, well really it's 2 parts. Create an encode object with the offset, and then 2, create an encoded string using the encode method on the object with the message. That's what you need to do. The second part of this is create a decode method. So you need to create a method that will decode an existing message the same way. So it does the opposite of the encode method. I don't give you the code for this one, but let me ask you a question. If this encode method takes each character and adds the offset to it, if I wanted to decode the same message, what would I do? You subtract the offset. So you just take this code, make the appropriate changes, put it into your decode method. Then here, for this test, you do the same thing. You create another object using the offset, and then you call the decode method, and you pass it the message. So this should be the decoded message. That's it. That's your lab 7. If anything's going to slip you up, it's going to be those last 2 tests. But for my money, at this point in the class, This is the easiest lab in the whole class. Pretty straightforward. Now, I also said we're going to briefly cover Lab 8. So let me go to FSO and pull that one down real quick. The Lab 8 is going to be a synthesis of the entire class, and it's the last project you do before you do Practical 2. As such, you will need to use everything that we have learned so far, with the exception of an enumerator. You don't need to use an enumerator. So I'm going to open up Lab 8 over here. Here we go. So, the first thing you need to do for your Lab 8 is you need to create a student class. The student class will have 3 fields: first name, last name, and student ID, which will be stored as an integer. You're going to make 2 constructors. One is default constructor, one is an overloaded constructor. By default, your student class will create a default student that has empty strings for the first name and last name, and an ID number of 1 million. That is 1 with 6 zeros. So that is going to be your default student. In addition to that, you will need to make getters and setters for all of your fields. Once you've done that, once you've created your overloaded, your default, your getters, and your setters, your student class is done. Test 1, overloaded student constructor. You're going to create a student and return a student using the provided values. That's the first name, the last name, and the ID number. Test 2, you don't need to do anything. This is just creating a default student, so this will just work, assuming you have your default students set up correctly. Test 3, insert into a collection. Search the student vector for the first default value and replace that value with the enrolled student. That is this student here. So search through this vector, try to find an empty space, add this student to it. If you were able to do it, return true. If you weren't able to do it, return false. Again, 1 return in this class. Just because I'm saying return true and return false does not mean we're going to have multiple returns. And these must have comments still. Number 4, remove from a collection. Remove the first student with the matching ID number by replacing that student with a default student. So again, here's an ID number, and here's a collection of students. You're going to look through this collection of students to try to find a student with the ID number, and when you find it, you're going to remove it. If you were able to find it, you return true. If you weren't, you return false. And then finally, retrieve from a collection. Retrieve the first student with a matching ID number from the collection. If no student is found, return a default student instead. So again, you're given a default ID, you're given an ID and a collection of students. You will search through that collection of students, looking for a student with a matching ID. If you find it, give me the whole student. If you don't, give me a default student. Does this sound familiar? Do you understand what I said? If you were paying attention today, you will pass the class. As a reminder, 3 things open. As a reminder, Lab 8 is worth 8% of your grade. Practical 2 is worth 20% of your grade. That is 28% for those of you keeping track. Midterm is 15% of your grade. This is now 43% of your grade, plus professionalism, which is 10% of your grade, which nobody has lost yet because nobody has cheated. So that's 53% of your overall grade in those 3 assignments. You need a 59.5 to pass. So this is your guys' opportunity. You know now what you need to do to finish the class. If you have any questions about those things, be sure to ask. If you don't have to figure it out right now, you guys have until Monday to complete Lab 1, or Lab 8, Practical Practical 2 is an extension of Lab 8. We'll talk about it later on, but you will need to do all of those things to complete that practical and a little bit more. Again, we exceptionally don't accept paperwork because I have to have all of my grades mostly finalized by end of day on that Friday. Presumably they want me to have them done by Wednesday, but I pushed that over till Thursday. A little bit of leeway there for myself. But again on Friday, those registrars want to leave here, rightfully so. So we gotta have all that stuff in. So do not allow the gag on that one for sure. Like I said, you guys have until Monday to complete these two, right? Get your practical one as done as you can. That's the one you want to work on until midnight if you have to. But these guys, get on them as soon as you can. Get your questions answered, because if you can pass this, you're good forever. Any question about any of that? Yeah. Yeah. Yep. It only exists within the scope of the loop. Any other questions? Alright, you guys don't have any questions? That is all I have for you today. I will see you all again on Friday. Friday, we're going to do all this over. The whole thing. So. Alrighty, we have our poll. We're just gonna hop right into it. Just gonna be. Oh, I have to change my display capture. Hold on. It's gonna be here. So let's go to there. Let's see if I can get my camera to work again today. Yeah, hop into there. I'm checking this camera stuff. Not that camera, this one. Oh, it worked. It did it. It might. Alright, so this is the best animated film of all time. Previously we did animated show for children. This does not have to be for children. WALL-E is a great one. One of my personal favorites. Shrek 2, of course. Of course. Lion King is a great one. So for me, like, this is either going to be like Spider-Verse, Puss in Boots, or any one of those Disney Golden Age movies, right? Lion King, Beauty and the Beast. Context of this class when we get to that point. Yes, that's it.
No, there is only two. Maybe.
7 is probably the easiest lab in the class for my money. 8, but that game is excellent. I'm gonna do IO, pretty much all covered. Either one will work, so work in the same file. Are related to the amount. You go down until you find. Yes, here, we're gonna get right into it. I am going to create an application that can represent cars. I like car. Designing our. Now, can anybody guess why I now have 2 of these? And we are going to your bowl. Which is going to be. Oops, not that. Not that. Alrighty. Let me actually switch this. And there we go. You guys hop on in there. So as a reminder, practical 1, done, dusted, closed. Yeah, hopefully everybody did their best. Like I said, campus students, you guys did great. I'm not concerned. Online students, most people are also doing great. Very few people falling behind and struggling, which is good to see. But then again, if people don't participate, I just don't know. So those of you that have been communicating, paying attention, letting us know on Discord, sending me messages, good. If you are watching this and you have not been, now is your time to start doing that. We only have a few days left, and I don't want to make sure anybody gets left behind in any of that stuff. But I do want to make sure that everybody has a chance, everybody gets the grade they deserve, all that stuff. All right, so let's get on here. Oops, no, let's actually run this. So this one is a live action movie. I had to make this one on the fly a few months ago because I'm running out of slides. I don't have an opinion here. There are too many good movies. It's much easier for me to nail down an animated movie than a live action one. Heat is a good one. Good movie. Is it you, Cuspede? Yeah. I figured it might be you. You know, I have not seen Cruella, and I forgot that I haven't seen Cruella because of, I was just looking out, watching it the other day. I was like, oh, that movie does exist, I want to see that. I only heard good things about it. Die Hard classic, Princess Bride classic. You know, when I put this slide up and I was thinking through all the movies of all the things that I think are like my favorite movie of all time, Tropic Thunder was literally the first thing I thought of. But like, I can't say with definitive, but like, with like any certainty that Tropic Thunder is my favorite movie because there's just so many good movies, man. What? Yeah, you do. Yeah, no bad answers here. One bad answer here. Okay. No, yeah, all good answers here. All right. Next up, what do you guys need me to cover? We are now complete. By the way, the class is effectively done. We're gonna learn some other things like memory and storage and stuff like that. We'll go over some basics of how things are run through a computer. But at the end of the day, we don't have any new programming concepts to cover. So we are at the end of what we were going to learn in PG1 when we learn object-oriented programming. From there, it's just you doing more stuff with objects, looping, conditional statements, methods, all that good stuff. So if there's anything you would like me to cover in particular, let me know. But today, I imagine we are going to spend a lot of time in our Pokemon demonstration because it synthesized the entire class, and we have a lot to flesh out in it. All right. Nobody has any questions. Let's get right on in. I got to put on my programming tunes because we're going to go hard in the paint today. Let's get at her. Let me check something out real quick. We have a shockingly small amount of people online. So let me just make sure. No, yep, it's shared with all sections. We just had a very steep drop off of people joining the online lecture. Alright, well, get on it then. Okay. So Visual Studio. Alright. So this, as you may recall, is our Pokemon demonstration. In this, we've done stuff like user input validation, as well as creating a cool method to display stuff. I am going to take some time to comment this user input validation. You will need to do this in your practical too. Oh, and also, hold on. Hello? My audio is going to be bad because I didn't plug in my microphone. So hold on. They're just plugging my webcam, which it uses my microphone. Yes, use that. Thank you. Yeah, I mean, you probably heard me fine, but you're going to hear me better now. Yeah. Alright. So, just a real quick review of this user input validation. We're probably going to have to do this more. This is not a thing that's going to go away. Depending on how I decide to structure this project this month, we're probably going to come back to that. I do it different every month, which is fine. It keeps me thinking, keeps me on my toes, gives you guys an opportunity to see how like the development process works, because I have to like piece things out, kind of find solutions to things. There are some ways I would prefer to do this, but I don't usually keep notes. All right, so this is a method that's designed to prompt the user for input, right? As a result, it is going to get data back, all right? Because we're going to prompt the user, we're going to grab something back from it. So I have a string return. So as always, once, right? Because I want to do this all at least once before I even try to validate it, because I'm using results, which is the variable that I initialized up here, as my condition. So if a result is still empty, we don't validate the input. So we're going to say clear screen. We're going to prime the user. We're going to prompt and capture input here, and then we are going to display error text if needed. I don't think anybody had a problem here as far as comments go. Most of you guys had really good comments, but this is the type of commenting I'm looking for, essentially. Right? We don't need to have one on every line, but definitely on every few lines for meaningful chunks of code, right? Like I could say like clear screen and prime user. I could combine these two. I get prompt user and capture input. I can combine these two. Displaying user error text. That's fine. But this is the amount of stuff that I'm looking for, right? Like I said, you guys, campus students, you guys are doing great as far as I recall. But for online students that are still wondering or kind of got knocked for not having enough comments, this is the amount of stuff I'm looking for. Alright, so we're going to minimize those things. We're going to open up a new file. So remember how I did previously we made a new class, right? We made a new class, we made it in a header. I'm going to make another class here because it's going to make my life easier. Now, this is not something that you guys are required to do in this class, but given the scale of the Pokemon project, it's going to be something that I need to do. Now, I'm going to come over here, and I'm going to make a new header file. I'm going to come over here, new item header. I'm going to call this UI.hpp. Now, there's two different ways I can do this. I'm going to do it the way that I don't like to do it, but the lab instructors would prefer I do it to remove confusions. I'm going to make a new UI class here. And the purpose of this class is going to be only to hold my UI components. I'm going to make a constructor. We're not really going to need it. It's not going to do anything. And we're not going to have any member variables. So now I can just take these methods, right, that I created here, and paste them in here. This will allow me to just keep all of my UI components in one place, right? So if anything messes up with my UI, if I need to find anything that has this UI related, I have one specific file that I have all that stuff in. I'm going to need to implement IO stream here. I don't think I need string. No, I do need string instead of get line. So we need IO stream, and we're going to need get line or string. And it might change later on. So we made a new class, and we moved over those methods. So now over here, I can make a new UI object called UI. We don't need to call the constructor, but we do need to include UI. So we include UI.hpp. So we say a new, I don't know why my tabs basically done all that stuff. That's weird. A UI. So it's the UI class, the variable called UI, and we're just going to call all of these methods on that UI object. Just like that. So now they all just exist under that UI class. And if I need them, I just call them from that object. Easy. This keeps my whole project very kind of succinct. And we're going to need to do this for a few different things, right? We're going to need to create a few different classes for this whole thing. All right. So right now, we're doing, hey, welcome to Wonderful World Pokemon. What's your name? We get their name. We welcome their name. And then we're going to say UI.display message box. And we're going to say steals a bunch of Pokemon. It's like, yeah. It's I don't know what theory's on, but alright. So user we get the player name, we get the rival name. Cool. Yeah, I made a separate class here. We split it up. I made a separate class. Oops, I did horizontal split, not a vertical split. I gotta do a vertical split. I'll right click, vertical group. Second class, and I just moved my method. I made it I gave it a constructor. And I want to call these, right? I create a UI object, so let's do some comments here, right? We're going to say here, this is the required default constructor, right? And then this is the UI object, and then we call it the object. So we include the UI. So we include local files. And these are going to be include the library dependencies. So these are library dependencies, these are local files. And then these are just our methods. So this is going to this introduction. That's what all this is. So we're going to copy these three. I'm going to bring these two together. And this is all going to group together too. Player name, prompt. This is the rival name prompt. There we go. You shouldn't be able to do that unless these are marked as static. Like, if they're marked as static, then you can call them directly on the class. But you still have to call them on the class. You have to do, like, UI and then call a method. That's typically how I do this. I'm not doing that this month. But that is an option if you could just call it. I can't do that. So I don't know. It's going to say it's not defined. So I don't really know. I have to see it. I can take a look at it maybe during a break or something. If you want to send me a screenshot. The UI.hpp is where I am going to store the user interface methods, right? So the main method is still going to be a list of all the things that happen in my project. So it's going to be here. We're going to go over to the user interface. One thing, we're going to do that stuff. We're going to come back here. We're going to go back to the user interface. We're going to go back and forth, right? But actually, I'm going to break this up even more. We got to do a lot of organization today because this project is going to expand quickly. I mentioned this earlier, like way long ago when we first started creating this project. But effectively, what we're doing here is we are creating an engine that is going to allow us to flesh out our Pokemon assignment, right? Which means we need to build a series of tools in order to make this happen. The first tool we built was the display message box. The second tool we built was prompt user. And then from here, we're just going to expand on that, right? So, I'm going to keep, like I said, I'm going to keep all my user interface components. So actually, I can go over here and I can make a comment on my class. And I can say, class to hold user interface components, right? Put a comment there. And now when I mouse over this class, it's going to say, class that holds my user interface components. And just create it. So I'm going to leave a comment over there. I can see it over here. This is called self-documenting code. Like I will say here, is a given message in a formatted message box component, right? If I mouse over that now, display a given message in a formatted project. Like if I do any project at any kind of scale, I try to have self-documenting code like this. Every single language has some type of documentation built in. All right. Any questions about this so far? We're basically doing what we already learned as far as week 3 stuff. That is creating a class, creating an object of that class, calling methods on that object, right? So we just aren't passing any data to the constructor. We will do that eventually, but we are not doing that yet. So any questions about this so far? Cool. We're gonna do this again. We're gonna do the same thing again. I am now going to create another class. And this is the first time that I've done this whole object pattern. I don't normally do this. So again, I do this differently every time. There are inevitably going to be pitfalls that I have to overcome. So I'm going to create another new item. And now I'm going to create a new file. This is going to be called events.cpp, or HPP. So this is going to be a series of events that I'm going to use for my game. So I'm going to call this class events. Again, we're going to make a default constructor for this. So I'm going to call this events, and I'm going to put a bracket there. We're going to say required default constructor. And now I'm going to break my game up into a series of events. So right now we're going to have a std string introduction event. I need to include UI, which should give me access to string because we already included string in UI. And then I'm going to take all of this stuff and I'm going to put it in here. This says does not say introduction. All right. So now we have all of those things in here. I can remove the UI.hpp here. And I'm going to do events.hpp. Now, I'm going to make a new events object, and I'm going to say events.introduction. And I can tell you right now, I'm going to organize this one level deeper, but we're going to do that as needed. So let's review all the things that we did, right? Because we didn't really change much at all. We just moved stuff around into separate files. Number 1, we took our 2 methods that we already had, right? And in the two methods that we already had, we moved them to a new class. In this class, we just have those 2 methods. We copy pasted them wholesale. We didn't do any changes to them really. And we made a default constructor so we can actually make an object from the class. This class will continue to hold our user interface components. There's other user interface components we're going to have to try to make, like a menu component. We're going to need to be able to create menus. This is where that's going to be. And any other things that we decide are part of the UI. Like I could maybe make press any key to continue. I will probably make this its own method because I use it a lot, but we'll see. And that'll exist here. Number 2, I have a series of methods, right? A series of method calls here that create the beginning of the game. I just took those and I'm going to group those up in this events class as well. So same thing we did with the UI, right? We just took some stuff, created a new method here, took that chunk of code, put it into here. This way our main method now only has a list of events. I'm going to continue doing this. Anytime our main method gets like more than 20 lines, that's probably a good indicator that I need to like refactor my code and abstract some of this stuff out. Those are the terms we use, right? Refactor means revisit and change how the code works. Abstract means taking some of those things and moving them elsewhere. Like when we take a chunk of code and we move it to a method, right? We say like, oh, we've done this a bunch of times. We can probably put this to a method. That's abstracting that code and putting it into a method. So I'm going to continue doing that. I'm going to be abstracting chunks of my code, turning them into reusable tools, and keeping my project as simple as possible, right? Inevitably, right, there's a balance between making enough files versus removing enough lines of code, but story of the project, one of the websites that I created, right? There is I think I have it here on my desktop. So I have a bunch of websites that I maintain. I've maintained them for a very long time. And the problem with these websites, they're websites that I created when I was a very young child. I was in high school. I was about 16 years old when I started this whole journey on becoming a professional developer. As a result of that, right, I was with a lot of people that were around my same age, right, like 16 to early 20s, that were doing similar stuff. Particularly making video game music and making websites that host video game music. That's how I met all of my composer friends. By the way, I kept saying that my boy Wilbert Roger is gonna win a Grammy, and the Grammy nominations for interactive media just came out. So the Grammy nominations for Best Video Game Soundtrack and Interactive Media, and I'm not lying when I say my boy Wilbur Roger is going to win a Grammy, because he's nominated twice. He's nominated both for Star Wars and for Helldivers, and he's going to win for Helldivers. I'm just saying. Yeah. That's a great question.
They got robbed because Star Wars is up there.
That was my, when I said Wilbur Roger is probably going to win a Grammy, the probably was only if Claire Obscure isn't up here. Because Claire Obscure is got a good running, right? Star Wars, as much as I love Star Wars and as much as I love Will, has no business being up here. It's never gonna win. It's just up there because it's got a good soundtrack. Will is like one of a small handful of people who has worked directly with John Williams, and he's like the short list of people that can do Star Wars music. But that is like fully just like an acknowledgement of his effort, his achievements. He's gonna win for Helldivers. That is the same thing with Indiana Jones, right? Indiana Jones is the same thing. This is just another John Williams soundtrack, and as much as I love that game, it's not gonna win. Austin Wintory is actually great though, and it's really good to see him up here too. Anyway, that's my aside. So I started this community. I made my own websites. As time went on, those people grew up, and they didn't want to maintain their websites anymore because they moved on to other things. But again, 16-year-olds making code. So one of the websites that I inherited is this website here. And now the quirky thing about this website, let me close this. The quirky thing about this website is, again, made by a child, and as a result, it looked pretty well organized to him at the time. Hold on. Come on, open up. It looked pretty well organized to him at the time, but here's the problem, right? This entire website, I mean the entire website, exists within this one file. It is broken up into methods at least, but it exists within this one file, which is, yes, nearly 6,000 lines. This website will never be updated. I would more likely rebuild this website from scratch and abstract the data than fix this. This will never happen. And as a result, this website hasn't been updated in 20 years. Don't do this. This is what we're trying to avoid, and this is why we're breaking our project up into multiple files. Because there's not even any comments in this. There's like nothing. So the only stuff that's commented is stuff that he commented out. So this just worthless to me. Just worthless. It's just good method games though, it's like he wasn't a bad developer, but this is not something I can use. So those are the kind of things that we're trying to avoid. Alright, so we have our events here. So we're going to go through this process. Anytime we need to make a new event, we're going to go into the events. Anytime we need to make a new UI component, we're going to go into the UI components. I'm going to go through here and I'm going to make a series of events that I will fill in later. I'm going to make them all void right now because I don't know if I need data out of them, but fix them, we can refactor this and change it later on. So from the introduction, we wake up in our room, right? So Red, Ash, whatever you want to say, they wake up in their room, they futz around with their computer, they look at they maybe play their Super Nintendo, then they go outside into the world, right? From there, they make a big decision of whether or not they want to touch grass. Touching grass is actually a deadly sin in Pokemon. If you do it, Professor Oak gets really upset with you because, let's be real here, there's bugs in the grass, and bugs are incredibly dangerous in the Pokemon world, I guess. Finally, we have the Pokemon selection. We're going to do a void here again. So Pokemon selection. This is where you go back to Professor Oak's lab and decide which Pokemon you want to have. And then after that, if we have time, which we may, we'll see. This is where the rival battle is. So we'll have a rival battle. So these are our basically our to-dos. These are our series of events that we need to go through in order to finish the demonstration for this game. So this is our goal. We are currently though at 1:55-ish, we're gonna say. So we're gonna take our first break. Come back here and we're gonna start fleshing these guys out. As tools are needed, we will start developing those, and we're going to use all the things that we have learned so far. So object-oriented programming, creating methods, conditional statements, loops, collections, all of it. All right. So, yeah, I saw your DM. I'm going to take a look at that in a second, and I will see you guys back here at 1:10. So we'll be back in a bit. Bunch of really good, clever things that I said, and now the delivery is off. So you guys are just gonna have to take my word for it that I said some clever stuff. Really clever and insightful. All right, display message box. We do need the player name here. I'm now realizing. So we're gonna take an ASCII string player name, and we're gonna say player name plus equals wakes up in their room. A bit of an aside, right? I am going through this. I am setting up methods. I am setting up classes. I am calling methods. Like I said, everything we're going to do from this point out is review. However, I fully recognize that people may still be struggling with creating methods, doing loops, calling a method, getting stuff out from a method, making an object, all that stuff. So if you are struggling with this, if I'm going over something that you need to understand, you don't quite have a grasp over it, slow me down, right? The more you guys don't slow me down, I have a tendency to speed up. So I'll try to keep the brakes on myself, but just let me know. So created our UI object, we are calling our method on it. We are passing down the player name as our parameter. Player wakes up in their room. Now, this is where we're going to say, what do you want to do today? Because like in Pokemon, there's several things you can do from the seated position in your room. You can go back to sleep, you can play video games, you can go on your computer, or you can go outside, right? Because you start in that room, those are typically the things you can do in that room. That, to me, right, is a multiple choice menu. Right? There's multiple things that we can do, and as a result of that multiple choice menu, I'm going to want to start creating a mechanism that we can use to interact with the menu, right? Because we don't have that yet. Remember, I said Pokemon is nothing if not menus. So what I'm going to start by doing is I'm going to start by just creating all this raw code, right? I'm just going to put it all here, and we're just going to have it. And then we're going to identify parts that we can like abstract in order to turn it into a method. But for now, we have to find the solution first before we can start improving on that solution. So, first thing I'm going to do is I know if I'm going to need a menu, that's going to be a set of several items. And if it's a set of several items, I'm probably just going to use a vector for that. So I'm going to make an std vector of std strings, and I'm going to call it menu options, and I'm going to make it equal to or initialize this data. So we're going to say go back to sleep.
Menu
We're
choice.
going to say play video games. We're going to say go on your computer. And we're going to say
Input.
go outside and maybe touch some grass. So there we go. Those are our Pokemon options. So semicolon here. And now we need to display these menu options. So I'm going to make a loop. Which is going to be a for loop. I'm going to use a for loop because a for loop is going to allow me to loop through a range of predefined items, and the position is going to be important. So for loop is a great option here. So for loop dot size. Menu options dot size I plus plus. That's got a bug in it. Let's see what comes. Menu options plural. So we're going to start counting to 0. We're going to stop counting at 1 less than the size. And we're going to count by 1. So we're going to increment by 1 each time. So I could do something like std cout menu options I. Kind of thing I can do. But this is just going to list them all. Actually, also with the end line. Because I want them all to be on different lines. Alright, so this will do line by line. But this is not great on its own. I actually want to have like the numbers there. I want to have like, what I really want to do is I want it to look like number and then text, right? Because that way they can enter in like 1, 2, or 3 to make a select from the menu. We saw this briefly when we dealt with our enumerator for the last demonstration we did, right? So we're not going to do that here. We're not going to use an enumerator, although I could. But what I am going to do is I am going to create this little box. Now, since I want this to be sequential, right? 1, 2, 3, 4. I already have a counter that counts that. It just starts at 0 instead. So if I add 1 to this counter, it'll count 1, 2, 3, 4. Right? It'll do what I want to do. So we know we can use that I for that. And beyond that, I just need to concatenate my strings. So we're going to say a open square bracket plus in parentheses I plus 1. Nope, because that's a number. We're going to use the insertion because that'll graduate it to a string. So I plus 1, and then we're going to use the insertion again, and we're going to use close square bracket and a space because I want a space between that square bracket and my text. So that looks pretty good. Opening options. I'm gonna test it. We're not really interacting with it right now, but I do want to visualize it. I've done a lot of coding without testing it. So what I'm gonna do is I'm gonna come down here. I'm gonna say events.wakeUp, which means we're immediately gonna go from these things into the wake up event. And I need to pass the username. Do we return the username? We do. So we're going to say std string player name is equal to events dot yada yada. And then in here, we're going to pass down a player name. So again, we're doing a lot of moving and shaking, right? We're doing a lot of passing around data now. It's very easy to lose track of data when you're moving around a bunch of different files, a bunch of different classes, a bunch of different methods. This is why breakpoints are super helpful, because they can help you understand where now, which file am I in, which line of which method in which file am I in, and does the data change? How does the data change as I move around? I'm probably not going to need to do that, but you can very quickly see when the application starts to grow must return a value. I do not have a return statement in the introduction. So we need to return name. We don't have a return here, so we're going to return name. See if that does it. So the edu will allow me to set like a set of things that I can select from. Whereas just making a vector, I can make it dynamic, right? Otherwise, I need to make an enumerator for every time that I need a menu, which just doesn't make sense. But if I have, if I can just do it based on the vector, I can just pass a different vector of items every time. So you'll see what that looks like when I actually abstract this out into a method and start reusing it, because I will need to use it several times. All right. So, welcome, wonderful Pokemon. What's your name? My name is Doug. Welcome, Doug. So now we know for sure that data is getting passed in and hopefully passed back out. Late in the 50s, grandson's name, you know by any chance. Name is Gary. Cool. Doug wakes up in the room. So that, excuse me. So now we know that came out of our introduction method and then into the wake up method. And now we should see menus. So this is our menu. We know we probably want a clear screen before this, but that does look like a menu. That does look like a thing that I can select stuff from. So that's pretty good. So minor usability tweaks here, but we're on the right track. All right. So closing events, because we're not working on that. We're going to go to, actually we are working on that. We're still working. We're not in UI yet. So let's go back to it. Close UI. All right. So we're going to go back to events. Back down here. Wake up. So we have this. So Doug wakes up in the room. We're going to say system clear. So clear the screen. And then we're going to say SDDC out. What do you want to do today? I'll do an inline. I probably want to do a new line and an end line. So that's two lines. So we're going to say ask them a question. Oh, here, let's do this. Clear screen, ask a question, provide some options, and then capture their, so display options, and then we're going to capture their input. We're going to capture their input. Yep. So we're going to do, we could do validation here. We could do user input validation here. I'm not going to worry about it right now. That's going to be too many things for me to tackle at once. My brain is small, can only do one thing at a time. So we're just going to capture the input, and then we might add validation later. It'll be relatively easy to validate it. But like I said, one thing at a time. I don't want to overcomplicate this. So we're going to say SDDC out. Choice is fine. And then we're going to say STD string choice is equal to an empty string. We're going to say int selection. It's dumb for me to use two separate names here, but it's the first thing that comes to my mind, right? Like I said, I'm not going to make the smartest choices the first time I go through this, and this doesn't need to be final, and this doesn't I don't want to overcomplicate this too much. I want to keep this in terms that I can simply understand right now, because if I just try to throw everything I got at this and try to do validation and all, and this is, once I'm going to get overwhelmed and I'm going to get lost and I'm just not going to know how to do it. And this is me talking about this with 30 years of programming experience using PG1 concepts, right? Now, I could get overwhelmed. So I'm going to keep this as easy as possible for myself, and I will extend and I will add to it, and I'll do all those things when I feel comfortable doing that. I do not feel comfortable doing that now. All right, so we're going to say get line, and we're going to say STDC in, and I'm going to take in first our string choice. Are you talking about displaying is a vector of strings. These are all comma separated, so each one of these is a separate position in the string. And then I loop through that, right? So I loop through that. So I go each item at a time. I get that with this right here. So menu option
I think
I,
it's
this will
time
start
for
at 0, and it'll end at 1 left to the side. So it'll go 0, 1, 2, 3. Put some comments in here, right? So this is going to be 0. This is going to be 1.
I'll be back.
Maybe 2.
Time for an
This is gonna be 3, right? So it's gonna go 0, 1, 2, 3. In front of that, I added this little square box. So we saw that when I printed it to the console, right? So this little square box, what this will basically